Welcome, folks. In this session, what I'm going to do is to give you a PowerPoint presentation on the Autoflight Director System operation taking off in a VNAV mode. What we're going to do here is give you all the indications that you should be noticing and monitoring during the takeoff. The one thing that I would like to emphasize again, the importance of what I'm going to call situational awareness, because it's been my experience, especially in new hire training where you've got a lot going on. And even with experienced pilots, they do not either know or watch the sequencing of the Autoflight Director system during a takeoff. And that's pretty important to keep in mind, that the operation is proceeding as it's supposed to, but more importantly, there are indications during the takeoff roll, which I will cover, which will be helpful if you have to alter that takeoff with an abort or a rejected takeoff. Now, the other thing that I want to cover here is to show you the operation. Any airline, any operator is going to have some call outs, some procedures that are associated with a takeoff. And in some cases, some of these indications. I'm not going to cover that. We're just going to cover the sequence of scans and watching the operation, and you apply your own specific procedures at a given airline. So with that, we're going to get started here. What I want to cover is this situational awareness. I do want to bring up a point, as I maybe mentioned in some previous sessions here. It really is a weak skill, especially early in training. And that's understandable because you haven't absorbed a lot of information. But as you go through your training, feel every day I've grown a little bit in my ability to absorb this information and improve my situational awareness. Now, in the case here of what we're going to be doing with this particular module, there is a static condition that I'll show in the first slide here that really requires situational awareness of you seeing that everything is set up proper on both sides of the cockpit for takeoff. Now, one of the things that I see very often, and again, even with experienced pilots, you think you just monitor your side of the cockpit. My gosh, gang, don't do that. That whole cockpit is yours to use your eyes on. And it's important that you develop that discipline, develop that skill, that you are constantly looking across the center console over into the other pilot's area to see what they may have set up, what is being indicated over there. And so again, I'm going to emphasize that with one of the first slides. And then after that, you're going to be in motion. And then there's going to be a sequence of those situation awareness that is important. So we'll continue, we'll press on here and get started. Now, the one thing that we're going to do with this PowerPoint is we're really going to primarily emphasize the Autoflight Director operation and the scans that are associated. This area is the most demanding learning curve in training, especially if you have no previous experience. So be aware of that. Know that you've got to study hard. You're going to have to dedicate a substantial portion of your personal time. Go practice when you can with some devices prior to your actually training periods and get this scanning down so that it becomes a second nature. One thing I've pointed out here is by the time you get near the end of training, you ought to be confident that you yourself you know these sources, you know how to scan, you know what to look for. Be confident that you have some assurance within yourself that you know the system. Now here's what I've got set up here as a cockpit that is, let's say there's a number of things here that you're going to do that I'm going to cover that would be done on a checklist. There are other things that you would maybe set personally. Here is a cockpit, an entire cockpit, and there is a setup of information here that you as a pilot ought to take a moment, even if you've done things with a checklist, is to see that the aircraft is set up specifically for this takeoff. And we're going to cover some of those things. And I'm just quickly going to point them out. For instance, up here on the mode control panel, a course would be set that maybe is left to you. Maybe airline has a procedure on it, but this happens to be the runway heading in this case. And of course, the SID, it has an altitude that be set to, and you should scan and see that that is appropriate. Now, in this case over here on this course selector, again, it's maybe not used in a LVNAV takeoff, but you can put something over here that's maybe appropriate. And this, for instance, is an engine failure heading. And then you have your heading set up to the runway heading, which is indicated on your maps. The other thing that you want to confirm, and the checklist probably took you through this, you have your auto brake set up for rejected takeoff, you have your flaps set appropriately, and that it agrees with what's in the FMC. Now, the one thing that I really want to point out here, gang, is that some systems will give you a takeoff warning horn if the flaps are not set to a takeoff position. One of the things that is important to confirm, even though you probably use this on a checklist, and that's why I have it outlined in green here. Most operators would have you use a checklist to see that the flaps are set properly for takeoff and where you have auto brake set appropriately for what your airline procedure is. But here's the thing I want to caution you on. When I look at this flap setting, I want to make sure that it's the flap setting that has been called for in the FMC. The flap handle is not in the takeoff position. But what it doesn't do is give you a warning if you have a takeoff flap setting in the FMC and it disagrees with what you actually have here. So for instance, if this takeoff in the system required a 10-degree flap for takeoff, and I had 5 set, we would not get a takeoff warning horn in some of the earlier versions. I think some of the later versions have corrected that. But in any case, what you want to do is scan it without any checklist or anything, but as you're waiting to be cleared into a position or as you're going in the position, start to do all these scans here that I'm about to continue to cover. So we wanted to check this. And the other thing, when I look here, this is a reduced takeoff, not a full power takeoff. And you want to see that up on your thrust mode annunciator, that is what you have up here. We're looking, I see here, at 93.3, and that's what it's calling for here. The next thing that you want to scan, and again, some checklists maybe would have you set this up, but some maybe don't. They just expect you to know that operation. But LNAV and VNAV are engaged. Now, this green light here on the mode control panel means nothing. I want to emphasize that again. It means nothing because I want to make sure that the computer knows that mode is, in this case, armed and ready to activate. So with VNAV, I have VNAV set up in my pitch window of FMA, and then I want to see that LNAV is in the roll window. So I should be cross-checking and doing that all on my own. Now, the other thing, too, that I want to point out is that when you look at the FMCs that are in the cockpit here, they should be on useful pages. I tell you, that doesn't occur all the time. But generally, certainly a legs page is useful for a flying pilot. And this takeoff ref page, which is going to automatically turn into a climb page, should be set up. And then the last thing that would be an important thing to check, and that is that the nav displays are set appropriately for what the individual wants or something that is useful. In this case here, one on the right is set to 80 miles. The one on the left is set to 80 miles. The one on the right is 160 miles. So make these scans, see that double check things are set up properly for takeoff, and you're ready to go. Now the next step here, what we're going to do is on the throttles, we're going to engage toga. And when we engage toga, the thing that we're looking for on our respective FMA is that it went to takeoff power. The takeoff power is indicated by N1 in the speed window, the auto throttle window, and that you have takeoff power applied. So what we're looking for in this case here, when we engage toga, we already start to see the speed is increasing. I can see that we're at 25 knots, but I have takeoff power applied. Our FMA indicates that we have it, and we have seen that that takeoff power has already come up to the reduced power takeoff of 93.3%. Now, when we get to 60 knots, let me go back here because I forgot something, gang. I apologize. When I engaged toga, prior to this, we did not have a pitch bar, a pitch cue. We had the roll cue, but not the pitch cue. So when I engage toga, the cue is going to come into view on both primary flight displays. Now, when we get to 60 knots, the pitch cue is going to come up to the projected V2 position. And that's important to note. Now, the next indication you're going to get is a change from N to throttle hold at 84 knots. That's important to note, and I'll explain the reason here shortly. The other thing that I would really suggest you all get in a habit of, most pilots during takeoff, they look out the front window. Even the pilot monitoring is a fixation out front, never coming back into the cockpit to look at the takeoff. Very few pilots will scan, especially the engine instrument area, in case there is something that is a trend that is a problem with an engine or one of the engines. And so what I want to encourage you to do as you get into this range here, and as I'm trying to encourage you during a takeoff roll, do at least 3 times monitor. Glance over here. It's a pretty easy thing to do. Just glance here, and I can see when I get there, especially the pilot monitoring even more so, but certainly a pilot flying can also quickly look over here, and I'll show you in the next slide what can be an indication that maybe something's going on and I maybe need to consider looking a little closer at what that might be. But the point is, at 84 knots, you get this throttle hold, and notice that's an indication you're going to get on both sides. Now, what's important about this throttle hold is that functionally it gives you the opportunity to manipulate the power even with the auto throttle on, and it will hold the power setting that you set. Now, the other thing that's important about this is that if for any reason after I saw this, I have to reject a takeoff, I'm going to be 90 knots or more, and the auto brake system is going to be active. That's another reason this is an important indication. Now, I'll tell you, there's generally a lot of discussions in the pilot world about whether I can do a better job braking or whether the aircraft does with the auto brake system. I will tell you that there is no way a pilot can be as effective in using manual brakes on a rejected takeoff than giving it to the auto brake system. Number one, the way the auto brake system operates is that it immediately goes to a brake level, a max brake level, such that it skids and releases the brakes to a non-skid condition. And then it applies the brakes to a stop. The other great thing about the auto brake system is that it'll keep you tracking down the runway, even with an engine failure. When we as pilots manually try to apply the brakes, we're constantly going into braking, skidding, braking, skidding, braking, skidding, and consequently a longer distance is covered during a rejected takeoff. So what's important about this is if I have to reject a takeoff after this point, I have got the auto brake system that is going to be working for me. Now here's what I want to point out. This is maybe the third time that I would maybe take a quick look at the engine instruments here, and that's just prior to V1. Now the one thing that I put up here is if you see the compressed version is expanded down here, that means the system is set up that's telling you that there's something going on with an engine that brought this up and it's trying to get your attention. Now, it may be an oil pressure, it may be an oil temperature or something that's out of range, and that is maybe at this point you might want to consider, or earlier in the takeoff, you might want to really consider rejecting the takeoff rather than taking an engine problem into the air. And in this case here, I'm just giving you an indication of how it'll go from this compressed version into an expanded version here if there is an engine problem. Now, I can tell you realistically, guys, and I'm just trying to be honest with you, I was the same way. Others give you an indication that they don't look at this because I, as an instructor, can put a problem in here, let's say at 90 knots, and it's never noticed between 90 knots and V1, and it's not noticed until after flaps are up. So please get in the habit of scanning during the takeoff roll. All right, so now here we got to the rotation speed and V1 speed, and we've made a rotation, and the pipper is up into the pitch bar. And notice that initially it's going to take you up to about 15 degrees. And with that, you're going to see that the airplane, it takes a while for cues to settle down. So we're still increasing airspeed. But be patient with that because this pitch bar is gradually going to give you a speed that'll go back to the speed that it engages closer back here to V2 or up to V215, V2 plus 20 in the case of the 800. But in any case, what I really want you to show, and what's important here too, is we are airborne. We're looking for that indication here. But what's important to note is that armed LNAV at 50 feet AGL goes into a command mode. That's 50 feet, and that's an important cue to notice that transition has occurred. Now notice here what's happening this with the pitch bar again, as I had mentioned, is that it's still attempting to settle into a speed here where we're going to stabilize this from accelerating. But at this point, what is important, what I'm trying to emphasize to you is that we're approaching an altitude here where VNAV armed is going to transition into a command mode. So notice on both sides here, you know, the pitch bar is going to stabilize. I think you'll see in the next rotation here. Now, at 400 feet AGL, this is going to go into VNAV speed mode. That's when you take off in VNAV. At 100 feet, that is going to make that transition. Now, the one thing that I want you to notice at this point here, notice that the pitch bar has moved up here and it's asking us to pitch a little bit higher here. We're going to come back to this V2Q. So that's what you're looking for, and expect it at 400 feet. You're still going to stay in takeoff power. Now, at this point, what we did is engage the autopilot on the mode control panel. And anytime you push a button up there, it's not the illumination that's on the mode control panel that means it's engaged. That means nothing. This on your FMA and your primary flight display annunciator tells you that you have engaged the autopilot and it is working in a command mode. Now here we've got to a point of 1,500 feet, and at that point, this is going to change into a climb mode. And that is all predicated on what is set up in the second page on the FMC. I missed a little bit of an explanation on that, but notice that at this point it's transitioned into the climb mode. The climb mode now is coming back to N1 of 88.7. Notice that's what's up here. It's automatically going to be doing that. This is telling me that I'm in that mode and I'm climbing in VNAV speed. Notice here now in this transition, since we're in VNAV and we're at flaps 5, the speed has gone out to 230 knots. The aircraft, if we did nothing with it at this point, is going to accelerate to just 230 knots because the flaps are at 5 degrees. Now, the one thing that I want you to notice too is that in this case here, we are beyond this white, call it caret or Q, and the present flap configuration that you have of 5 degrees, before you retract the flaps to the next setting that you want or your procedures call for, you want to be above that speed Q. So right now, if we wanted to retract the flaps to 1 degree, we could do so. But anyway, notice here too that we're in the climb mode. Let's transition into the climb mode from the takeoff. Now, here's something that's important. We decided we're going to retract the flaps. Your procedures will call for whatever your airline does. Generally, that is a call for a pilot flying to call for flap retraction to 1. Now, with that, when I call for flaps to a position, I want to notice that my partner heard it and is making that move. And in many cases, it's probably repeated as part of a procedure. But I want to look and see that the flaps are retracting and there's no asymmetry or any other kind of problem. Because if you're going to have a problem with the flaps having an asymmetrical condition or a condition that is going to be skewed, this is where you're going to notice it. And notice it as soon as possible. So when I call for that, I want to see that the flaps are in fact making that move. And so notice now that I mentioned the speed restriction for us right now is 230 knots. Now we have flaps at 1, and as we are approaching the 1 position here, the indice on the speed tape, when we reach that 1 position, that is when we call for flaps up. You normally would, your airline procedure may be different, but that allows you, because we're accelerating, we're going to go from the min speed of flaps 1 to a min speed of flaps up. And in that transition from 1 to up, you will have accelerated up to that up speed. So what we're going to do is call, in this case here, we'll call for flaps up. I want to make sure that I see that's heard by either procedure repeating it or that my partner's hand is going over to the flaps. And then I want to look up here and make sure that, in fact, the flaps are retracting. Now notice that once we go to flaps up now, and we're still in that transition here, notice the flaps are moving now and we're accelerating to there. But what we now do is have no restriction on a flap position setting, and we are operating by the speed that is commanded in the FMC. So that's why we're seeing 250 knots here. And then most airlines now, once you get to a point where the flaps are up, you'll probably have a procedure from there. But here's a time where you can just either on your own or by procedure, go ahead and turn the auto brakes to the off position and the landing gear handle from the up position to the off position. This pretty much does what I want to do in this first phase of this takeoff. These are important things to be able to note are happening, note when they happen, and scan to see that they're happening at the appropriate time. Hope this has been helpful. Now, tomorrow or in the next couple of days, what I'm going to do is have an actual time takeoff up to flap retraction with actual simulation and the timing sequence from the time that we engage toga to a final flap retraction. So you're going to see that sequence in real time. But it's important to get these steps down, these scans down. And I'll tell you, by your third session in simulator training, all of these indications, all of these steps should be really well enough established that I can do the sequencing of this in a normal professional manner.